Hi everyone, I am Milan Mondal. I have done my masters from a very reputed university of India, the Bardwan University. Then I have worked 2 years for PG physics teacher in the Kendriya Vidyalaya. After that, currently I am working in an institution at PGT physics teacher. Again, I am doing freelancing and also working as home tutor, and also in different website I am teaching advanced physics. Okay, so here in this platform I will just teach you physics and different problem regarding that advanced physics and some topic of mathematics. So today I will discuss you electrostatic dipole. So let us start. So first we will see what is dipole. As the name suggested, you can see dipole mean there should be two pole, and it is electrostatic dipole we considering. So when two electric charges equal and opposite are separated by a very small distance, then that configuration called as a dipole. So two equal and opposite charges separated by a small distance is called electric dipole. So let us draw how we can draw a dipole. Now that arrow is already present, we'll use that arrow also. Just suppose this is a minus q charge and this is a plus q charge, and we can take the distance as L also, but to solve the numerical easily, we divide these at two equal part of length, and you're taking both part as L and L. So the total distance will be 2L. When we'll do calculation, we'll understand that why we are considering that distance as a two part. So actually we are considering this one is L and this one is also L unit. Now this middle point we are taking a reference O. So this is a configuration of dipole. And why taking this dipole? So actually, in case of electrostatic, already we know electric field due to a single charge, electric field due to single charge Q at a distance R, we know that electric field is nothing but kq by r square, where k is 1 by 4 pi epsilon naught. Now, actually, when you're considering any material, that material will not consist of a single electron. Definitely, that will contain a very large number of electrons. So, to make the actual electric field calculation very easy, we are taking this kind of configuration. Not only dipole will configure, again with 4 charges we can configure quadrupole, and 8 charges we can configure octapole. According to our requirement, we will do that. So this is the basic one. Now, this dipole is defined by a term which is also very important, called dipole moment. So dipole moment is a vector quantity that is defined as the product of the charge and the separation between the charges. You can see, so you can see charge is Q and separation between these two charges is 2L as we have taken. So this is the dipole moment. And we can see dipole moment is a vector quantity, and from here we can see the direction of dipole moment will be from minus charge to the plus charge. So you can show this dipole moment like that. So our P is dipole moment and that arrow represent the, and it is a vector quantity. So this is a very important quantity called dipole moment. Now we'll find electric field due to this dipole at different position. So let us first find electric field along the axis of dipole. So now we'll find electric field at any point on the axis of dipole. So let us see what the quantity will comes out. So first we are drawing the diagram of a dipole as we have already shown. We are enlarging this because we are also considering the distance where we have to find the electric field. So here we are taking that our minus q charge. Again, after some distance 12, we are taking plus q charge. And the middle point we are taking to be O. And we know from minus q to O L distance, and from O to plus q again L distance. So that two distance also we can consider. From this point to that point is L unit definitely. So you can take either L meter or L centimeter. Now here we will take only as L unit. And again, this one is also L. So here we want to find the electric field at a distance R, from the point O on the axis. So that is our R distance and this is our point. We are taking this point as A. So actually we can see here from the middle of the dipole, from the point O, we will find electric field at a distance R at the point A. That is our main job here. To do that, what we will do, we will first individually find electric field due to this minus q charge and plus q charge. Then we'll find the net field or resulting field. So you can see, first we can see minus q charge is at a distance L plus R. You can see from minus q charge, the distance of the point A is L plus R. So we can find the electric field due to minus q charge. We can find the electric field due to that minus q charge. And we're representing that as E minus. So you can see E minus, that definitely it's a vector quantity. So E minus, we are taking the magnitude. So we know that is K and charge is Q divided by what is the distance? L plus R. So L plus R, that's square. That is E minus. And definitely we can see at the point A, due to minus Q, the direction of electric field will be towards the charge. So we can take this is the direction of E minus. How to find that direction? At any point, if you place a unit positive charge, then the attraction force on that unit positive charge will give us the direction of electric field. So if we place a unit positive charge at the point A, you can see that unit positive charge will be attracted by this minus Q along its own direction. And that is the direction of electric field due to this minus Q charge. Similarly, we can take, better we are taking that is our x-axis and that is I cap, unit vector along x-axis. So we can write this vectorically, E vector, as you can see the direction is negative x-axis. So we can take that is minus I cap. Now again we can see from this plus Q charge, the distance is from this point O to that A point, distance is R. So from that R, we have to minus this amount L. Then we'll get the distance from plus Q. That means the distance of this plus Q charge is R minus L. So you can show that one also. That distance I'm showing. Actually, this is the distance. So that distance actually, you can show that one. This distance is R minus L. So similarly, we are just denoting the electric field due to plus Q charge is E plus. And definitely you can see, again, if you put a unit positive charge at the point A, due to plus Q charge, there will be a repulsive force. So along I-axis. So electric field due to this plus Q charge is along positive x-axis. So we can take it like that, KQ by R minus L square into I cap. So we have got both the field. Here you can see we are getting electric field, which is vector quantity. So for two charges, we have got electric field, two electric fields. And from two vector quantity, we know how to find the total electric field. That will be vector addition of these two. So you can write net field, net electric field E equals to E minus vector plus E plus vector. So what we are getting finally, we are getting, you can see that E will be, we are taking first E minus, that is KQ by R plus L square. And you can see that is minus I cap plus KQ divided by R minus L whole square I cap. So rewriting these equations, what we can take KQ to be common, and this K is nothing but 1 by 4 pi epsilon naught, where this epsilon naught is the permittivity of free space. So KQ, and then you can see that we are getting 1 by R plus L. We can take that due to, first we can take due to that plus charge R minus L square minus, this minus will be there, 1 by R plus L square. Now, then from this step, what we are getting, you can see KQ, and definitely I cap will be there. So KQ, and if you can see R minus L into R plus L, that whole square. Now you can see first term containing R minus L square. So for doing LCM, we are getting R plus L square minus R minus L square. So what that term is coming, we can find that one, like R plus L square mean A plus B whole square. So that is R square plus 2RL plus L square, and minus, you can see R minus L square, R minus L whole square mean R square minus 2RL plus L square. So you can see here R square cancel, L square cancel, and 2RL minus this minus and this minus become plus. So we are getting 4RL. So what we are getting finally, KQ 4RL, and we know R minus L into R plus L, that is R square minus L square and whole square of that, and 1 I cap. So you can see this is our electric field. Now, what we will do here, if you consider a short dipole, short dipole means separation of the between two charges of the dipole is very, very small compared to the distance where you're finding the electric field. That means R is very, very greater than L. What you can do then, if R is very, very greater than L, then you can see L square will be very small quantity. L square will be very small quantity compared to R square. So for that reason, we can write R square minus L square as R square, because L square is very small compared to R square, because L is a small quantity. So L square will be smaller than that also. As a result, we're neglecting that. So finally, the electric field we're getting KQ 4RL, and here you can see R square minus L square is R square, and R square that square, so R to the power 4 and along I cap. So you can see 1 R cancel out. So we finally getting KQ 4L by R cube into I cap. Now you have to remember one thing, as already I have discussed, for the dipole, the main parameter of the dipole is dipole moment. So again here, we'll try to write this quantity electric field in terms of that dipole moment. So already we know that dipole moment P is nothing but 2QL, because 2L is the separation between these two charges of dipole, and Q is the charge of the each charge of the dipole. So here you can see from this term, you can consider, you can write like that 2QL, and you can see Li, L into I vector, that is L vector. So that will remain with 2K by RQ. So that we can write 2K, and this physical quantity is nothing but this physical quantity is nothing but by the dipole moment P vector. So 2Kp by RQ. So this is our final reading. Electric dipole, due to electric dipole, field, electric field at a distance R along the axis. So here you can see our resultant field also you can see along I cap. So this will be the direction of net total field, and also along this same axis. First we are writing this as direction of E plus. Then the resultant field also along the same direction. So along the same direction we have net field, this direction. Thank you. Have a nice day.